Thank you, Jeff, for your introduction. So yeah, I am Simone Devrel at IoTeX. IoTeX is a blockchain-based platform that aims to connect data from machines in the physical world with blockchain applications in the blockchain, in the Web3 space. So I don't know how many of you have participated yesterday. Yesterday we had a setup session where I just went through some technical details about what is required to make this workshop, to successfully run this workshop. Although, of course, it's not easy to make sure that it will work on everybody's computer, because you may be using different type of operating systems and different types of softwares and packages, so it could not work. But in any case, I'll try to make it work on my side. And if you cannot complete it, then anyway, keep in mind that I will be following a tutorial that we have on the developer portal, step by step. So you will be able to do the same later after the session. And if you anyway have any issues, you can join our Discord channel. Let me actually share it in the chat, which is at iotex.io/dev discord https. There you can tag me or find other people from IoTeX that will help you with this tutorial. So with that said, I want to share my screen. If you have already configured your Windows system or your Linux system or your Mac OS, then you can start from a terminal. If you have not, yesterday I've showed how we have on the developer portal. If you go to my personal profile at developers.iotex.io/users/Simone-Rom, then you will find these two contents here. Create an IoTeX developer account and fund it with test IoTeX tokens and run a WebStream node in Windows. Yesterday we went through both of them, but I think the longest setup session is in this document here, how to run a WebStream node on Windows, because regardless if you're using Windows or Linux, you will have to install Docker. But in Windows, you also have to install the Windows Linux subsystem, WSL. And so I've shown here I've collected here all the commands needed to install WSL on Windows, and then how to install Docker inside WSL. I've also added some notes to the document that are required if you also want to edit or create a WebAssembly module for the logic of the WebStream node. And I'm introducing these things now because in case you want to do the configuration while I'm speaking, you can start doing it now and save some time. Another thing, if you want, I will deploy a smart contract during this workshop. If you want to run it entirely and do the same, then you will also need to install have Node.js installed in your system. Now, assuming you are using Ubuntu either on a native Ubuntu machine or inside Windows, you will have to install Node.js if you want also to deploy the smart contract. So I'm not included here the instructions, but it's pretty easy. If you go to if you search Google for install Node.js on Ubuntu, typically I use the DigitalOcean guide here, how to install Node.js on Ubuntu 20, and specifically I use option number 3 to do it, because that's the one that works. because the default Node.js version for Ubuntu is very old for some reason, and it doesn't work with any software. So you will have to use option 3 here. And let me paste the link inside the chat. And with option 3, you basically just run this command here to install the latest version of Node.js, and then you either restart the session or you run this one to apply the configuration. After you have installed NVM, then you will be able to install Node.js using NVM. So you can just do this NVM install and install whatever version you want. I suggest installing 14 or 16. I'm assuming you're starting from an Ubuntu terminal, either on an Ubuntu machine or inside Windows WSL. In Windows, you just, if you have installed WSL, you just open the start menu in Windows and you should have an Ubuntu application that will open for you a terminal with inside the Ubuntu system. So as I said, if you have not installed Node.js, you can use these instructions to do it, and then to install NVM, and then after you have installed NVM, you will be able to do NVM install and the version of Node that you want to install. In this case, for example, I already have some installed, so I will just install number, I don't know, 15. I don't have it, but you better install 14 or 16. So it will just download and install the version that you selected, right? And then you can use NVM to select whichever version of Node.js you want to use. If you have just downloaded one, it will use that one by default. Otherwise, you do NVM use 16, and it will use the version 16 if you have it. And I don't know if it's pre-installed or not, but in case you will need to do also to install npm, the Node Packaging Manager for Node.js with sudo apt install npm. I already have it installed, so I'll not do it. But if you don't have it, you can install it this way. So that's the only missing software that you may need if you also want to follow along and deploy the smart contract for this workshop. So let's get back to the developer portal, developers.iotex.io. What we will be doing, we will try to make this Machinefy app get started work. So I will follow this one step by step today. But before I start doing it, I think we have enough time today. So before I start doing it, I want to introduce again a little bit what we will be doing, right? So yesterday I quickly introduced what is a Machinefy application and what is a web stream. I think it's important to repeat this concept shortly. So a Machinefy application is basically a decentralized application that runs on a blockchain, and it uses data that's coming from machines in the real world. Machines, when I say machines, I mean any device that can autonomously run and generate some sort of data. So typically it's smart devices or IoT devices in the general sense of the word. So a Machinefy application is typically made of 3 basic components. One component is the smart contract, or is the blockchain component, which is basically a set of smart contracts that implement at least a token economy for your application. Typically, it's a rewards type of token economy or payment, or if it's a more advanced financial application, and it could also include DeFi concepts like staking, like, I don't know, lending, borrowing, or a marketplace, or NFTs, or even a gaming component, if you have any gamification aspect in your decentralized application. Then you have the IoT layer that's not running the blockchain typically because of the limitations of blockchain in terms of storage, cost, and speed, and computation, and privacy, and all these limitations of the blockchain, which is perfect for decentralized trusted logic like financial logic, but it's definitely not good for IoT logic, for IoT requirements. So for the IoT layer, we have an off-blockchain network, and we have this WebStream framework that allows you to create such a layer, currently only in the form of a single node type of architecture, but in the future, during 2023, we will develop further the WebStream framework, and it will also allow you to create a fully decentralized IoT cloud layer, right, off the blockchain. So currently, WebStream will allow us to deploy a single node IoT layer that sits in the middle between blockchain layer and the hardware layer or the firmware layer. The firmware layer is actually any sort of component, hardware component and firmware and software component together, which makes basically your smart device. The smart device is doing whatever type of processing and data collection. Could be a personal tracker device, a health device, could be a smart car, could be an industrial machine, could be anything, a vending machine, anything from which we are interested to gather data, and this data has some value for some reason, and so we want to inject this data inside our MachineFi application and use it to I don't know, run our data marketplace or run our data, I don't know, AI model, or just collect this data and make it available to other parties and generate a token economy inside our ecosystem where everybody is benefiting from either using the data or contributing the data to inside our MachineFi application. So these are the three components of a MachineFi application, and each one has its own complexities, of course. Somehow the blockchain component is the easiest one because it's like something autonomously running and it's secure by its nature. If you write the smart contract correctly, you can just deploy it to the blockchain and just forget about it. For the IoT logic side, things become more complex, and that's why we are creating WebStream, which makes this layer also more simple. And so the IoT part, the IoT layer, WebStream, is where the more complex IoT logic happens. It's where all the data is collected. That's where there is some device authorization, data verification, IoT logic processing, and IoT data storage. Let's say on the left side here, right? On the right side of a WebStream node, you have the blockchain communication part. On this side, the WebStream node is is both monitoring your smart contracts on the blockchain to react to any action that happens on the blockchain inside your smart contracts, and it's computing proofs of facts that happened based on top of the real world data that has been collected inside WebStream, and these proofs can be injected inside smart contracts on demand to prove something, whatever we want to prove, right, to trigger our token economy. This is one MachineFi model. We call it proof of everything. Basically, you have the WebStream node proving something to a blockchain application based on the IoT data without having to send the actual data to the blockchain because you, for example, don't want to make this data public, or just the blockchain would not be capable to process this data the right way to autonomously generate proof. So you have these proofs just getting injected inside smart contracts. For example, if we are in this workshop, we want to build click and earn example where the WebStream node will generate a proof for the smart contract that the user has clicked 5 times on a device, and then as a result, the smart contract, upon this proof, will mint a token and send it as a reward to the device owner. Of course, that's a very simple application. It's not intended for production. It's not intended to be secure enough. Just intended to get you started with connecting some data from a device to WebStream to the blockchain application, and then close the loop with a very simple token economy that will reward the owner of the device. And starting from here, you will have to understand more complex concepts about how to make these applications secure in the future, how to make sure that data is not faked, how to make sure that many different aspects, for example, where the identity of these devices is stored, and how to make sure that people are not messing up with the data. Anyway, with that said, what we want to do today, right? First, we have to complete the 3 layers of our machine file application. So as I said, we have one blockchain layer where we have our smart contracts. In our application, we only have one single smart contract, which is just a very simple custom token that we call click token. And this token is a mintable token, meaning that when we deploy the smart contract, there is no supply of this token. But there is a mint function inside the smart contract that some authorized blockchain accounts can call to mint a certain amount of tokens and transfer these tokens to some wallet address. So who can call this mint function? We decide. The smart contract deployer, so the account that has deployed the smart contract, is also allowed to call the mint function and mint any amount of token they want. But also we have a list of operators where we can add more blockchain accounts that will be allowed to call the mint function. One of such accounts should be the WebStream node. So the WebStream node, which is this one in this purple circle, the WebStream node must be capable of calling the mint function inside the smart contract to be able to send the rewards to the owner of the devices after clicking the button, right? So when we will start the WebStream node, we have the option to set up a private key. And this is the private key of the blockchain account that the WebStream node can use to interact with the blockchain. And so inside the smart contract, we will have to authorize this blockchain account as an operator so that it will be able to mint tokens inside the smart contract, and not anybody else will be able to do so. So this is the smart contract side. Let's actually go and get started with our workshop. So as I said, I will be following this get started on the IoTeX website, MachineFi, deploy MachineFi the app. Okay, so I've introduced already what is WebStream. I've introduced the 3 layers of a MachineFi application. So for our click and earn application, we have 3 layers. The blockchain layer that implements the decentralized logic. In our case, it's just a simple ERC20 token that is mintable with some levels of authorization about who can mint. Then there is the IoT logic layer, which is our WebStream node, which takes care of collecting data from devices, storing some IoT logic, and generating proofs for a smart contract to run some logic based on the proof that has been created. In our case, the proof is nothing complex. It's just the WebStream node calling the mint function inside the smart contract directly, because we have a single node and we have a smart contract where we have authorized this and only this node account to call the mint function. And that's a trust relation between the node and the smart contract. So we are not sending any complex cryptographic proof here. That's because we are using a very simple architecture with a single node where we are the deployers of the node and we are the deployers of the smart contract. And we have configured the smart contract to only accept a call from this node to mint a token. So the mint function, when it's executed, it can only be executed by this node. There is nobody else. So if the node is calling this mint function, this means that the node has detected the conditions, so the proof that somebody has to receive a reward because they have clicked 5 times on a button. And finally, the hardware layer. So in this smart contract, we provided a simple sketch, a firmware for Arduino boards that will work on an ESP32. I have an ESP32 here, but on your side, you don't have to necessarily use a board because W3bstream also provides a web interface where you can also simulate the message that would be sent from an hardware, from a smart device, from your smart device. You just type in the JSON of the message, the way it would look like, and then just send it from the web interface to the node. So let's start from cloning the click-to-earn code, right? So we can create a click-to-earn folder and enter this folder. So create a folder and enter inside the folder. And then we clone the repository inside the get started folder, and we enter the get started folder. Okay, so I'm inside the get started folder. So let's take a look at what's inside this folder. So we have 3 folders, 3 subfolders that represent the 3 components, right, of our Machine-Fi application. One folder contains the blockchain part of our application, which is just a smart contract. And the W3bstream folder contains the logic of the W3bstream node, and the firmware folder contains the firmware for the Arduino board. So we are not going to use it, or anyway, you will not have to use it during this workshop, but we will go through it as well. So inside the blockchain folder, let me open VS Code. So you should be able to open VS Code even from inside Windows. If you have VS Code installed or any other editor that you prefer, you should be able to start it directly from the terminal with code dot inside the current folder. Okay, so I'm inside my folder. What I want to do, I want to just take you through the smart contract. So we have a smart contract inside here, inside blockchain, inside contract. There is a click token smart contract. So this smart contract is just a standard ERC20 token that we have imported from the OpenZeppelin library. We are also implementing the ownable interface, which means that we can use the only owner modifier in some of our smart contract functions to limit the use of these functions to the owner of the account. By default, the owner is the one that has deployed the smart contract. So the owner wallet is the one that can add and remove operators. Operators are just a list. This one is just a list of blockchain addresses that are operators in our smart contract. And who is an operator? An operator is someone that can call the mint function. That's, in fact, inside the mint function, we have a require that the sender, so the blockchain account who is calling the mint function, is included inside the operators array. So we are requiring that the sender is part of the operators and it's enabled. If so, then the mint function will be called with the destination account that the caller indicated and the amount of tokens that have to be minted and sent to this account. If anybody else is calling this mint function and they are not operators, this will just fail and the smart contract will revert and there will be no minting, okay? So I'm mentioning this because later, if you run your WebStream node, you will have to authorize your WebStream node account, blockchain account, to mint tokens. And so you will basically call add operator with the address of your WebStream node account to add it to the operators. And so that then the WebStream node will be able to call the mint function and mint some tokens to the owner of the device. So this is our smart contract. Not going into the details of what's else inside the blockchain folder, because this is basically just a blockchain project, and I've used Hardhat, which is a framework for developing and deploying and testing smart contracts on Ethereum that also works on IoTeX, because IoTeX is fully compatible with Ethereum in terms of smart contract development. And so I've just created the project, and I've created some scripts according to their tutorials. So if you are interested, you can just go to the Hardhat tutorial, right? They have some nice introductory tutorials where you can just start setting up your Node.js environment, you create the project, you write your contract, you test your contract, you do some debugging, and then you deploy to a blockchain, right? It's very simple, and I would suggest that's the best place to start if you want to get started with creating smart contracts. So that's basically what I did inside the blockchain application. So I have some scripts that will just compile the smart contract and deploy it to the IoTeX Testnet blockchain. And that's what we are going to do now, right? Now, yesterday, if you participated yesterday, you should have created a wallet account, because as you can imagine, we need at least one blockchain account to interact with the IoTeX blockchain and to deploy the smart contract and to interact with this smart contract, at least from the WebStream node when it wants to mint some tokens as a reward. So I'm gonna do it again today. In order to generate a blockchain account, we need a blockchain wallet application. So I will use Metamask, which is the most popular one for Ethereum compatible blockchains. It's metamask.io actually. Let's make sure you type the correct address here. Do not download fake software here. And I will download it for Chrome, Google Chrome. Add the extension. Okay, after you have installed the extension, I will pin it so it stays visible here. You have to go through the configuration of Metamask, so just okay. I don't have a previous backup, so I will start with a new wallet. It's asking me for a password to unlock the wallet. Do not forget this password. Okay, now it will ask me to save a backup phrase. This phrase allows you to recover your wallet at any time. So please store this phrase somewhere. It's 1, 2, 3, 4, 6, it's 12 words. And these words allow you to recover your wallet at any time, right? If you plan to use this wallet for storing any real token on an actual blockchain that is not intended for development, make sure you store this phrase in a safe place. Typically, you want to write it down on paper. So by now, I'm just copy pasting it in a file, a text file, to save it inside. MetaMask wants to really make sure that you have stored this phrase. And so it will start asking you these words in the correct order to make sure that you have stored them correctly. Okay, once you have put the words in the correct order, just confirm and complete, right? So now we have our MetaMask wallet. It has generated a blockchain account for us with this address here. We can also rename it just to make it more clear. And this is our, let's say, deployer. as the account that we will use to deploy our smart contract. Okay. So the next step is Metamask has created a blockchain account, but what blockchain is Metamask using, right? It's by default, it's using the Ethereum blockchain, and it's also using the mainnet Ethereum, meaning the blockchain that requires the real Ethereum token with value to send any transaction. But when you deploy, when you work with developing a smart contract, you never want to debug using real value, right? Real money. So we are going to use we want to use a test blockchain. And in this case, we are going to use the IoTeX test blockchain. So we need to configure Metamask with the IoTeX testnet. So we are going to add the IoTeX testnet blockchain among the networks that Metamask supports. To do so, you just go to the IoTeX developer portal, developers.iotex.io. You click Dev Tools and you click Add IoTeX Testnet. It will ask you to connect the Metamask wallet to the website, confirm, and then you will be able to add the testnet configuration to the Metamask wallet. Click here, configure, and approve, and also switch network. So now, if you click on Metamask, you will notice that there is a new network here, and it's also the currently selected one. If I drop down, there is both the Ethereum mainnet and the IoTeX testnet. Make sure you have selected the IoTeX testnet. Okay, this means that any transaction that you will send from this wallet will go to the IoTeX testnet blockchain. Also, the balance that you see here is the balance of the native token on this blockchain for this wallet, right? So we need some tokens now, because like in any Ethereum compatible blockchain, you need to have some native token, the token that's defined inside the blockchain protocol, to pay for the transaction. So you have to pay a fee when you send a transaction to the blockchain, and this fee has to be paid in the native token of the blockchain. For Ethereum, the native token is ETH. For Bitcoin, the native token is BTC, and for the IoTeX blockchain, the native token is IoTeX. So we need some IoTeX tokens on the IoTeX testnet. And so the best way, if you want to really start as a developer, is to register a developer account on the IoTeX developer portal. In your case, you just click sign in. You need to have a GitHub account to be able to sign in. So you can sign in the developer portal. And once you have signed in, you go to your dashboard here. And inside the dashboard, you can connect your wallet, right? So you will, if you have not connected it yet, it will ask you to connect. Once it's connected, it will show you your wallet address here. It will show you your balance on the IoTeX mainnet and your balance on the IoTeX testnet, which is 0. So you can claim some test tokens here to start developing. So I click claim, and at some point in our wallet, we should have some test tokens. The time for confirming a transaction is around 5 to 7 seconds. But there is also some time to do the claiming and the verification and eventually the updating of the UI. So the website is also checking that you have not claimed already. It will only allow you to claim tokens every 24 hours. So I've claimed, I have now 100 IoTeX tokens. You can forget about the value here because Metamask is not checking that we are on a testnet. So actually these tokens have no value. You cannot sell them, you cannot send them to any exchange or anything. These are tokens on a blockchain that is only used for development. It's not the actual, not the mainnet, but it's overall almost identical to a real blockchain, to the corresponding mainnet blockchain. So you can use it to test your smart contracts on the blockchain. So we have test tokens and we are ready, right? But before we start, so I will not make it too complicated, because we should now create a new blockchain account and use this blockchain account as the WebStream node account, right? And then authorize it inside the smart contract, inside the token smart contract, to enable it to mint tokens. But for the sake of simplicity, we will use the same blockchain account, both to deploy the smart contract and as the account for the WebStream node to send tokens, to mint tokens inside the smart contract. So at some point you will need the private key of this blockchain account. The private key is the actual account, right? The one that is used to sign the transactions. And we have to input this private key inside the configuration of WebStream, so that WebStream will be able to use it to send transactions to the blockchain on behalf of this wallet. So to show the private key of this wallet, you go to this three dots menu here, click Account Details, and then you click Export Private Key here. You input your Metamask unlock password, and you copy the private key. You should never share this private key with anybody the way I'm doing, right? I'm just doing it because these are test tokens and I'm going to get rid of this wallet account after the workshop. So, but you should never share the private key with anybody. So now that I have the private key, I can get back to our workshop folder. So the first step is to deploy the smart contract, right? So I will enter the blockchain folder. As I said, here I have a Hardhat project. It's already configured to deploy to compile and deploy the smart contract to the IoTeX testnet. By the way, this configuration is inside a file called hardhat.config.js. You can learn about these details on the Hardhat tutorials. But inside here, just want to show you, there is the URL of a gateway to the IoTeX testnet. That's where Hardhat knows where to deploy the smart contract. So inside this folder, you could run make deploy, which will use Node.js to build the project, compile the smart contract, and deploy it to the IoTeX testnet. But it will not be able to deploy if we do not provide a blockchain account that has some test tokens to pay for the deployment transaction. And this private key is the one of our Metamask account, because that's where we have the tokens. And so we can configure this private key inside a .m file. So I do nano. Nano is a very simple editor that any Ubuntu distribution has. But you can also use VS Code if you want. So I do nano.env. And inside here, I'm expected to export an environmental variable called IoTeX private key equals, and I paste the private key, okay, that I copied from Metamask. So to exit this editor, if you're not familiar, you just type Control-X, click yes, confirm with enter. And now we have created this .m file, cat.env, right, with the private key inside. This private key will be used by Hardhat to sign the deployment of the smart contract and send this transaction to the IoTeX testnet. And because this private key belongs to a wallet account that has some tokens, it will successfully deploy. Here is where you need Node.js and npm, right? So just to make deploy, this one is only running this command here, cat make file, this one. So if you don't have make, you can just run npm install and then this one to deploy. So make to install all the required packages. It will compile the smart contracts. The smart contract, it's compiling 6 smart contracts. It's actually only one. The other smart contracts are the ones that we have imported, like the base class that we have imported from OpenZeppelin. Then it tells us, the script tells us we are deploying the smart contract using this account. That's the corresponding address of the private key that we provided, right? That's the same of this wallet here. And then it's also telling us how many IoTeX we have in this wallet. You should divide this by 10 to the 18th because our custom token has like 18 decimal digits, and this is providing you the amount in the smallest unit. And then the script is also like enabling the same account that deployed the smart contract as an operator. So this account will also be able by default to mint tokens, to call the mint function. And finally, it's telling us, okay, I've deployed with this account, and this is the blockchain address of the token contract, right, of the contract that we have just deployed. And because it's a token contract, it follows a specific standard to be recognizable as a token, as a custom token. You can copy this one, and inside Metamask, right, you can also go into your assets tab and click import tokens, right? So Metamask is capable of recognizing the smart contract standard called ERC20. That's the one we have followed inside this smart contract to say, to tell wallets that this is a custom token. This is just an implementation of a token, right? According to the ERC20 standard. So if you input the contract address here, Metamask will recognize that this is a token. We have called this token click inside the smart contract, and that this token has 18 decimals. So you can just add this token and import it inside Metamask. So Metamask is now telling you your balance in the native token and your balance inside this custom token implemented as a smart contract. So this token is a smart contract. This token is not a smart contract. This one is the native token of the blockchain. This one is implemented inside the protocol of the blockchain itself, like the Bitcoin token in the Bitcoin network. This one is a smart contract token. So as you see, we have lost some IoTeX here because we have deployed the smart contract using this account. So we paid some fees here. Okay, we're ready, right? We have our blockchain wallet. We have the balance of our click tokens, and we will use this same wallet for everything, so we don't have to switch between different wallet accounts. So we will also use this wallet address as the owner, like as the device owner, so that here is where we will receive the token rewards, the click tokens rewards. So we have our smart contract deployed, right? Let's get back to the tutorial. Okay, we have deployed the click token. We did make deploy, and we deployed the contract address, right? And we have also imported the token inside Metamask. Okay, now here the tutorial is saying if you want to use a custom wallet account for the WebStream node that's different from the one that you use to deploy the smart contract, which should be the way to go, right? You should not use the same account because the one that deployed the smart contract has all the privileges to do everything on that smart contract, adding operators, removing operators. You should have an additional account that is only an operator and use it for the WebStream node to only mint tokens, but should not have other privileges to do anything else on the smart contract. But as I said, if you do it, just create a new one, like add a new account, and you will have another blockchain account here in addition to the deployer. And then you can use that private key of that account as the private key of your WebStream node, and you should also at that point run this script inside the blockchain folder of our repository and authorize your, not private key, but the address as the operator. So make it an operator, right? We will not do it. We will just keep using the deployer account. Okay, now we move to the IoT layer, okay? We have deployed our smart contract here, and we have a blockchain account that's the one who deployed the smart contract, and it's also allowed to call the mint function here and mint some tokens and send them to any blockchain wallet you want. Okay, so the best way to run a web stream node is by using Docker, right? That's why I asked you to install Docker, because that's the easiest way. You don't have to like deal with system configuration and packages and dependencies and things like that. However, anybody can clone the WebStream repository on the MachineFi GitHub account and just build the Docker image yourself, or just run from the source code, and the instructions are included in the repository README file directly. So, but if you want to run with using Docker, it's pretty simple. Before I go ahead, I want to save these two addresses here. The one that I used to deploy, where I have this one in Metamask, but the token address, I want to save it in a file. So echo this address in the token file, token contract file, just to keep note. I don't want to lose it because I need it later. Okay. So if you want to run a WebStream node, it's very easy, right? The first thing you do is you get the Docker Compose file. So I will do it not inside the blockchain folder, not inside the get started folder. I will do it in the root folder of our project. So in the root folder, we have the get started, and here I will fetch the Docker Compose file. Oh, sorry. Called docker compose.yaml. Okay, the reason why I do it in the root folder is because when we run our WebStream node, it will also generate some folders for the database, for the configuration and other things. So I don't want to mess up with the get started project. So these things will be generated inside the root folder. But before I run the WebStream node, as I said, our WebStream node will have to interact with our smart contract. So we need to provide a private key to sign transactions. And because the WebStream node will have to call the mint function in our smart contract to mint some tokens, we need a private key of an account that is enabled as an operator. So as I said, I will use the same private key of the same account that I used to deploy the smart contract, because that one is already enabled to mint tokens. I can take it directly from the .env file, cat get started blockchain.env. Okay, it's this one. So we have to export this one either in a .env file or as an environmental variable. So we can also just do export. It has to be called private key equals our private key. So I'm exporting it into the environment, and it will be picked up by the WebStream node when we run it. So to run the WebStream node, so we did this one, export private key, and then we can just run the WebStream node with Docker Compose up. It will pick up the configuration inside Docker Compose.yaml. So this may take a little bit of time depending on how fast is your internet connection. But that's only the first time when it will pull the WebStream Docker image along with all the required Docker images. Okay, it has already started the WebStream node, all the required services, as well as WebStream Studio. So let's verify that the node is running on the computer, right? So just access WebStream Studio. I'll on localhost 3000. So as you can see, you have the W3bstream Studio login interface. There is a default username, default password here. So I can directly log in and I get access to the W3bstream Studio for configuring my W3bstream node. Now, before I go ahead, just want to get back to the slide here. Right. So we are running the W3bstream node. I want to focus a little bit on what's inside, what are the features that W3bstream provides. So what you can see here is that the W3bstream node has two network service endpoints that can be used to communicate with the W3bstream node. One on HTTPS, one on MQTT, and more will be added in the future. This means that anybody can send an HTTP or an MQTT message to your W3bstream node. But in general, any message will be discarded by the node. Before the node can accept any message, whatever the message is, right? I'm not saying it's an IoT message, could be anything. So before the W3bstream node can actually accept any message, you have to configure some authorization. So a very basic authorization mechanism that W3bstream provides is through publisher accounts. So this is the easiest way for you to implement device authorization. Basically, you just create a publisher account. It's just a username and an access token. So you create a publisher, you give it a unique ID, and the W3bstream node will store it and also create an access token for it. And then you can use the publisher ID and the access token inside your message so that the message will be authorized by the WRbstream node events manager. And then once your message goes through the authorization step, depending on the WRbstream header that you have included in your message, this header will contain an event code that you define. You just define an event code that you want inside the header of your message. And then based on the code of the event, you have an event strategy configured inside your WRbstream node, which is just a set of rules, very simple rules that say if the event code of the message is X, then you run the function Y, right? We call these functions handlers because they handle a specific event code that's included in any message. So in a WRbstream node, you can configure one or more projects. There is no specific rule here. You can create as many projects as you want, or you can create just one project. It depends on how complex your Machine-Fi application is. Then inside a project, you define publishers, you define an event strategy, and then you have some logic, so the actual logic of your project. In our example, we only have one logic module that we call applet, and inside our logic module, we have one single handler, which is a function, and this function will receive the message and will just count the number of messages received, because every time we receive a message, it means that the user has clicked the button. And inside this message, we also want to include the recipient address where we want to send the rewards. So we are including the recipient address inside the message that's being sent by our smart device, so that the WRbstream node logic can take this message, count how many messages have been received. If at least 5 or multiple 5 messages have been received, then our logic will just extract the wallet address from inside the message and mint. So we'll call the mint function in the smart contract to mint one token to that address that's included inside the message, right? So that's all about it. We have to generate a message inside our device. This message should contain an header for WebStream to authorize our message and also route the message to the correct logic. And it should contain a custom payload. The custom payload depends on our application. We want to include a wallet account inside our message so that the logic will be able to mint a token every 5 clicks to that account, right? So a very simple logic. But in general, you're not limited, right? You can have even multiple machine file projects and one WebStream node. And you have one project inside your WebStream node for every machine file application. Or you can have multiple projects for one single machine file application. And inside one project, you can have one or multiple applets. Every applet is a WebAssembly module. And inside the applet, you can have multiple functions. Every function can be triggered by a specific event that you have defined inside of the event strategy. So it's very simple event machine here, right? So the configuration is entirely graphical, but the logic here, the applet, has to be created, right? The logic has to be created. So I would start from here. So getting back to our console here, if you have not installed JQ, I want also ask you to install the JQ utility. It's a very small one. You can install it with sudo apt install JQ. This is a very simple utility to format text in a JSON, like a syntax. So, and I'm asking you to do so because otherwise it's a little bit hard to read the log of the WebStream node. So I want to use this terminal here to show the log of the WebStream node. And to show the log, because it's a Docker image, you can just do Docker container logs WebStream container, and do -f to keep following the log, and also -n10. I just taking the last 10 lines of the log because I don't want to show the entire log of the WebStream node from the beginning. I will leave this terminal here open to follow the log of the WebStream node. I'm creating a new terminal. In Windows, if you want to open a new terminal, you have to go to the Start menu of Windows and click again on the Ubuntu application to open a new terminal. Okay, so I want to focus on the logic of the WebStream node, right? This applet here and the respective event handler that's inside. How you create an applet. As I said before, also yesterday, WebStream can execute this logic because WebStream integrates an execution engine which is based on a WebAssembly virtual machine. This means that you can deploy an applet or some logic in the form of a WebAssembly binary that implements these functions. And to obtain a WebAssembly binary, you need a WebAssembly compiler. And there are WebAssembly compilers for some major high-level languages like C++ or Rust or AssemblyScript or Golang. In this workshop, we are going to use Golang. So I still have my VS Code open here. So let me close the smart contract. If you enter the WebStream folder, that's where we have the logic of our WebStream node. So inside the WebStream source folder, there is a click-to-earn.go file. And this is our logic. So except for some basic Go modules, we are also importing this one. This one is a common file that we have on GitHub that implements the WebStream host functionalities. This one in the future will become a Golang SDK, and we will have an SDK for Golang, for C++, for AssemblyScript, for Rust, and other languages. By now, it's just a very simple file that you can import. This file is just making it easy to call the WebStream host functions. WebStream provides you some host functionalities, and these functionalities are some low-level functionalities. For example, logging some text to the WebStream console, or reading the payload of the message that has been routed to your applet, or writing or reading settings from the database, from the WebStream database, or, for example, sending a blockchain transaction to the blockchain, to the IoTeX blockchain or any other blockchain that you have configured, right? So these functionalities are accessible inside your logic. Plus, you can import any other Golang library to implement whatever logic you want. But in terms of interacting with the WebStream host, that's what you can do. That's listed in the host functions here. And to access these functions, we have a nice Golang file that makes it easy to call these functions without having to do any low-level calls. So our module is as simple as that, just importing some basic JSON and strings libraries and importing the Golang WebStream functions. You need to have a main function, otherwise your Golang will not compile. It's empty. And then you have your actual handler function. I called it start, but you can call it whatever you want. This comment here is important because the compiler will use this export comment to know how to call this function inside WebStream. We will see later where we use this name. So I just use the same name of the function, but if for any reason you might want to call this one different, you can just rename it here. So this is the actual handler. We are here. We are creating an event handler inside our module. So this handler is calling common.log. So common is this file that we have imported here, and it provides us the host functionality of the WebStream node. So one functionality is the log functionality, which allows us to log to the WebStream console. So the first line of our logic is just to log the fact that this handler has been called so that we can do some debugging, right? Just make sure that the handler is being called by the WebStream node when a specific event, a specific message is sent to the node. So it's just logging the fact that the handler has been called and also logging the event ID. Then it's using the get data, that data by ID, event ID. That's the WebStream host function that allows you to extract the payload of the message. As we said, we have a smart device. It's sending a message to the WebStream node. Inside this message, there is a header that's used by WebStream to authorize and route the message to the correct handler function. And then it has a payload. This one is custom, whatever you want. In our case, it contains the account where we want to send the rewards to. But we need to access this payload at some point inside our logic, right? And to do so, we have a get data function here, right? This is what gives us the payload of our message. And this is provided by this function inside our common library here. We pass the ID. The ID is provided by WebStream. The ID of the event is provided by WebStream when it calls the event handler. So we pass the event ID, we use the get data, and this will give us the payload. Then we convert it into a string, right? And then we use the JSON library to extract the account field, because our payload is just containing the account field that we extract, and then we log it to the WebStream console just for debugging reason. And then we have a count variable. We are using the host functionality, the WebStream functionality, to read a setting from the DB, from the database. So we have a setting that we call clicks inside the database. We increment this setting, we log it to the console again for debugging reason, and then we store it into database again. We have incremented it by 1. we store it in the database, in the WebStream database again. And so here is our very simple logic, right? If the count, so the number of times we have received a message is a multiple of 5, then we log that we are minting a token to the account that was included in the message, and then we call the send transaction function of the WebStream node, right? It's here. WebStream has some, like, this is called ABI. It's an application binary interface. That's what are the functions that this host provides to your logic that you can call. One of them is the send transaction, which will send a blockchain transaction to the blockchain. And we are calling it here, right? So send a transaction. Now, if you are a Solidity developer already, you may know that you need to interact with the smart contract. You need to know the ABI of your smart contract. So you should use Go packages here to import some Ethereum or Web3 libraries that can manage the ABI of your smart contract so that you can easily just call functions of your smart contracts directly from your code, right? We have not done so. We have just made it very simple. We know how the transaction would look like to call the mint function in our smart contract. And we just created the message, the blockchain message, that has only to be signed by the WebStream node and broadcasted to the blockchain. We know how it looks like, so we just created it, like hard-coded the message. So the message is just a blockchain message that contains the recipient address, the amount of IoTeX tokens, it's 0, we are just calling a smart contract function, and the actual smart contract execution payload, which is just the name of the function of the smart contract that we want to call, and the arguments of the smart contract. One is the recipient address, and the other one is the amount of tokens. It's actually, this one is the amount of tokens that we want to send, expressed in the minimum unit of the token. So remember, our token has 18 digits. So that's why sending one token is such a big number, because it's actually 10 to the power of 18. So we are calling the send transaction. Send transaction expects a message like this. And yeah, so the recipient address is going to be replaced with the actual smart contract that we want to call. And it's our click token smart contract that we want to call. So it's not this address, because I've already deployed it and it's different. And so in your case, it would be even a different one. So that's why I've saved the wallet address of my token contract. And it's inside my blockchain folder, cat get started blockchain token contract. So for me, it's this one. If you have lost it for any reason, you can still recover, because if you have added it to Metamask to show the balance here, you can still click here, click the 3 dots. You can just go to the blockchain explorer here and open this contract inside the blockchain explorer. And it's this one. Better you convert to the 0x format, that's the Ethereum format for addresses. So it's this one, the contract address that you can copy of your token. So it's this one for me. Getting back to our logic, so we want to call this contract. I'm pasting my contract address so this one is going to be here, and this one, account, is going to be here. Right. I'm also removing the 0x if you have the 0x at the beginning of the account, because in the payload of the blockchain transaction, it's not expected to be any like number format here. And that's it. We just log the fact that the transaction was successfully, or if it failed for any reason, right? So this one is our logic, very simple logic. And this function here is called, we decide when it's called, right? But in our configuration, this one will be called every time a new message is received from a device, from our WebStream node. So I'm saving the logic here, and now I'm entering the folder where this file is stored, cd get started WebStream source, right? And I have a make file here too, but let me show it to you. The make file is just calling TinyGo, so you should have installed TinyGo besides the Golang. And this one is the Go compiler that allows you to compile a Go file to a WebAssembly binary target. In fact, you can call TinyGo build. The output will be this one, click-to-earn.wasm, and we are moving it to a build folder. So inside our get started folder, you add a couple arguments here, but the most important one is the target. So we are targeting the WASI WebAssembly system interface. That's what the WebStream execution engine is based on. So you have to target WASI when you build the WebAssembly module. You need to avoid debug instructions, and that's the file that you are compiling, right? The click-to-earn.go. So you can also run this one directly if you want with TinyGo build -o click-to-earn.wasm, exclude the scheduler, no debug, target WASI, and you are compiling the click-to-earn.go. Or if you have make, you can just do make. Okay, so now we have created, if inside like back folder and inside the WASM folder here, we have just created a click-to-earn WebAssembly module, right? That we can now install or deploy to our WebStream node. So let's get back to our WebStream Studio. Okay. So before we can deploy any logic, we have to create a project here, because a project is a container for publishers, authorization, for event strategy, and for the logic of our node. So we have to create a project first. So we do create a project now. I will call it click to earn. Now here you have to be careful, because this name is case sensitive, and we need this name exactly as it's written when we send the message from our board. Because when we send a message from any smart device to a WebStream node, we have to call a specific endpoint that includes the target project we want to send the message to. So make sure whatever you write here, you make sure you use the same name later. So I'm creating the project now, and I have a new project called click to earn. Now, inside this project, I can add an applet. That's the WebAssembly module that we just created. So now you can select the WebAssembly module here, but if you are in Windows, most probably you do not know where to go here, because under WSL, you will not easily find the folder where you have your click-to-earn repository cloned. I have added some notes inside the developer portal content that I created. So developers.iotex.io/user/Simone Rom. Here, run WebStream on Windows. At the end of this tutorial here, I added some tips for WSL on Windows. One tip is that you can run any software from inside the terminal, for example, VS Code. But also you want to know where if you want to know where your Linux files are on Windows, you can just enter your home directory inside the terminal, and you run explorer.exe. Oh, there should be a space here. Yeah, you should add a space here. So just type cd your home directory, and then you type explorer.exe inside the current folder, and in Windows this will open the file explorer inside the WSL Linux folder, and the folder will look like something like this: ///WSL Ubuntu something. So that's where your files are. So you can, I don't know, browse to just copy this one and browse directly to this folder when you are uploading the WASM file, and just locate the WASM file inside your Linux folder. Okay, so I've entered the get started folder, entered the WebStream folder. Inside the WASM, here is the WASM module that is going to make our applet, right? So I'm selecting this one. Select the project you want to upload applet to, and just give any name to this applet. This really doesn't matter. You can choose the name that is more convenient for you. I'm calling it, I don't know, handlers, because it contains my handlers, and submit. Okay, so now you have your project in the WebStream node. Your project, you uploaded an applet to your project, right? It's still like empty here because you have to actually deploy the applet, installing the applet inside the project. So if you click deploy, you now have an instance ID which represents your applet in the project, and it tells you that your applet is not running. You can start it by clicking start, right? So you have a project, you have an applet in your project, you have one handler in your applet, which we call start, and this applet is running at this moment. It's not doing anything because it will only do something when the WebStream event strategy will call the handler. So let's get to the publishers now, right? If you remember, we have to define a publisher, and this publisher has to be used inside a message for the message to go through the WebStream event manager. Otherwise, it will be rejected. So I go to the publishers and I create a publisher for my project. So this publisher will belong to the Click to Earn project of WebStream. I give any name to my publisher here. I call it Clicker device, whatever. And I give it an ID and clicker. Okay. This is also case sensitive. So remember what you're writing here. I create the publisher and I have it listed here for my project. So this is my project. I go to publishers and I have this publisher whose ID is clicker, and this is the authorization token that I can copy for this publisher. Okay? So if this publisher information is included in our device message, then the message will make it through the Node.js verification, and then it will be routed to the destination project, and it will trigger the respective event handler. But we still have to configure the event strategy here. So we go to the strategies for our project. As you see, there is a default strategy already added. So this one is just routing any message with, not any message, but any authorized message, regardless of what event code is inside the message. It will always trigger the start handler inside our applet. I called the applet handlers. But anyway, I want to delete this default strategy here just to show you how the strategy configuration works. So without any strategy, you can send a message to the WebStream node. You can also include the correct publisher to authorize the message, but it will not trigger anything because there is no event strategy set up for your project. So I will add the strategy and I will say, if a message or if an event in WebStream is raised with the code click and then I will show you where this code goes. So if an event with code click is raised, then you call the handler start inside the applet handlers submit. So this start here is this one. You can rename it if you want, and it belongs to this function. Okay, so I've created an event strategy that for this project that says if an event is raised with this code, click, then call the handler start inside the handler's applet. So we have everything set up here. Make sure your applet is running here, and our WebStream node is fully set up because we have started it, we have exported the private key for it to send transactions to the blockchain. We have loaded an applet inside the project. This applet has an handler defined. This handler will receive a message in the form of an event, and it will process the message payload, and eventually, if it's the case, it will tell the WebStream node to send a blockchain transaction with to a specific contract with a specific call data. So there is only one thing left now, and it's sending messages to this WebStream node. Okay, so we have our WebStream node running. Let's get back to our slide here. We have a smart contract that we have deployed. Our smart contract is simply an ERC20 token. It has zero supply when you deploy it, but you can mint new tokens by calling the mint function inside the smart contract. The mint function can only be called by those accounts that have been authorized inside the smart contract by the smart contract owner as operators. The smart contract owner itself is an operator in smart contract. So we have configured our WebStream node to use the same private key as the owner of the smart contract for simplicity reasons, so that it will be able to sign transactions using the same account of the owner of this contract. So if an applet is calling the send transaction, then will sign the transaction with that private key. So our applet is calling the send transaction to send a transaction to our smart contract and call the mint function. That's possible because the WebStream node will sign the transaction with a private key that's also owning this smart contract. This handler will be called when a message will be sent to this WebStream node. The message includes the correct publisher account and also the correct event ID that we have configured inside the project strategy to call our event handler here. So we should be able to send a message to our node. Now, I want to try it with the actual device here. So I will connect the board here because I just want to take you through also the actual code of the board, but later you will be able to do the same without the board. And I want to open the firmware folder here. So inside the firmware folder, there is a click-to-earn subfolder, and inside this click-to-earn, there is a click-to-earn.ino file. This is a sketch for Arduino boards, so you can just take this folder, copy it to your Arduino sketches folder. That's usually under your documents Arduino folder. Just copy it there and then open it with your Arduino IDE and use it to flash it to a board. I'm using an ESP32 dev module that you can find very easily on the market. If you also on Amazon, I guess. I usually find it with ESP32 dev module. Yeah, the dev kit, for example, this one, you should find, yeah, the ESP32 node MCU is also fine. That's the one I have. Or you can also use compatible Arduino boards. For example, the Arduino Nano 33 IoT is another board that works with the same sketch, but this one does not have a button. So you will have to also wire a button or use the pins to somehow simulate, not simulate, but implement a push button on the board. While the ESP32 has two buttons, one is for resetting the board, the other one you can use it to run the click-to-earn example. So this is the firmware. And it's made of two files. One is the actual firmware, the other one is the secrets.h. So the first thing you do, you configure the secrets.h with your Wi-Fi network and your Wi-Fi password. Then you have to configure the IP address of your WebStream node. That's where the board will send the messages to. So if, like me, you are running the WebStream node on your computer at home, and you are in the same Wi-Fi network as your Arduino board, then you just use your Wi-Fi network here, and you use the local IP address of your desktop computer where you're running the WebStream node. Then here is where you input the project name. So that's the one that we used here, the project name. This is case sensitive, so make sure you use the correct one, because this one will be used to send the message exactly to this project, and then eventually to this applet here. Then you have to set up the publisher ID and the publisher token, right? That's going to be used to create the correct message that WebStream will process and authorize. And WebStream expects that you have the correct publisher ID and token that you have created in the publishers here. So for the publisher ID, you want to use clicker if you configure it this way, and for the token, you are going to use this one. So you will write clicker here, and you will have your token here. Okay. For the rest, for the purpose of this workshop, you can leave it unchanged, but you have some more options here. If you want to send a message over HTTP or over MQTT, and what are the ports? And these are just default ports of the WebStream node. That's it. All the rest, yeah, this one is just has to be true because you want to include the clicker and the token in the header. So yeah, in my case, I've already configured it for my computer. So I've set my Wi-Fi password and name here. I've set the IP address of my computer. I've set click to earn. I've set clicker. And I want to show you the actual firmware. So the firmware, the important part of the firmware, the WebStream related part of the firmware. Keep in mind that we will also release SDKs for the most popular boards, including Arduino, that will hide most of the details of communicating with the WebStream node. But in this case, it's very simple, so it's hard-coded in the sketch. So as you see, we have an HTTP endpoint, and the endpoint is going to be created from the settings that we have in our secrets.h using the IP address of the WebStream node. Plus, it's building an endpoint that this is based on the WebStream API. And at the end of the endpoint, there is exactly the name of the project you want to target with this message. So that's why you have to make sure that you use the exact name for your project. And then we have another constant here, the event type or event code. And that's what we call our event, right? So yeah, you can choose whatever you want. Typically, you have one event code for every device model, so that you are authorizing that device, and you are routing the message for that event that belongs to that specific device model to a specific handler. So if you have different versions of your device with different versions of the firmware, then maybe send a different payload because you have improved something, then you can have different event codes for the different firmwares so that you in the WebStream node can route the messages from one device model to one handler and the message from another device model to another handler to take into account changes inside of firmware that you might have during the development of your product. So I'm calling this event click, right? I can call it whatever I want as long as I match it in the event strategy. If you remember, in the event strategy, where is it? In the event strategy here, I said when you receive an event named click, then you call the handler start inside the handler applet. Okay. So as long as you match it, you can choose any code that you want here. So eventually the firmware is just building a message, a JSON message like this one. That's the message that WebStream expects. So the message is made of two JSON objects. One is called header, the other one is called payload. The header is what WebStream processes. So inside a header, you have to include the event code or the event type. You have to include the publisher ID. You have to include a timestamp for when this message was sent. And then you have to include the authorization token of the publisher ID. If you include this information correctly, then the WebStream Events Manager will authorize your publisher data, and it will route the message to the correct project strategy, and based on the event code, it will route it to the correct handler to be processed. And then the handler will use the get data to extract the payload, this one. And that's this get data that you have here. Get data, event ID. So when WebStream calls this handler with the event ID, you can ask the WebStream node to provide the payload of the respective message for this event ID. And in our payload, the payload is supposed to be a string. So we are creating this string with using a JSON library for Arduino. So the JSON, we are using the JSON library to just easily create the header and the header object for our JSON message, and we include all the required fields. So the event code, it's the one that we define here. The publisher ID, we define it in the secret.h. Publisher time, we take it from the internet, and the token, we have defined it in the secret.h. And then we create the payload object of our JSON message. And our payload is as simple as just including a wallet account. So our payload is an account field. And here we have the blockchain account where we want to send rewards to. So again, for simplicity, I'm going to change this one. But actually, I'm going to do it in my Arduino IDE. Otherwise, I cannot flash it. So here is exactly the same sketch. I'm just going to change in the JSON payload, the account field. I'm going to change it with my Metamask account. I'm still, again, using the same wallet address for everything. That's where I have imported the click token address. So I see the balance I have in terms of click tokens. So I'm copying this address here, pasting it here. And so eventually our message sent by the device will look like something like this. There will be event type will be click. Pub ID will be clicker. hub time will be something like, I don't know, 170 whatever. The token will be our token, whatever it is. We take it from the publisher here. Publishers, this is the token, right? This is how it's going to look like. And then we have the payload, and our payload has to be a string. So it will be a string, and inside this string there will be our very simple payload, which is just an object with an account field, and the account field will be our wallet address. Now, because the payload is string itself, we cannot include double quotes inside, so you should actually escape these ones. So this is how the message will look like, the message that our port will send to our WebStream node. And the WebStream node will just count how many messages are received, because the board will send this message every time the user clicks the button. Right? And so our logic, our WebStream applet will get this payload. So we'll get this one. And then use this account address to mint tokens with this recipient here. Every 5 messages have been received. Okay, so I'm gonna flash this one to my board. So on the ESP32, after the compilation, the Arduino IDE will try sending the firmware. So on the ESP32, you have 2 buttons at the bottom. One is called EN, and it's used to reset, and it's the left side one. The right side one is called boot, and it's used for enabling the flashing. So when it starts connecting to the board, you push the boot button and it will start flashing. Once it's flashed, in my case, I have to push the EN button to manually reset the board. I'm also opening the serial monitor here to see the log from the firmware, from the board firmware. So now it's connecting to my Wi-Fi, to my home Wi-Fi network. This is the IP address of the board in my network, so that it can see the WebStream node running on my desktop computer. Now, just last thing I want to show you is that for the ESP32, okay, so this one is for the Arduino Nano board. Otherwise, it's the ESP32, we are setting the button pin to 0. That's the same pin where the boot button is wired to. Right, so we can use the boot button to simulate a click, not to simulate, but to actually click, and this click will trigger sending the message. We have an isPressed function that returns true when the button pin is low. That's because of the logic of this pin that's low when it's clicked. And so basically our loop is pretty simple. It's just checks if the button is pressed, and if it's pressed, it will just send the JSON message over HTTP to that specific project endpoint with this content that has been built by the JSON library. Yeah, this one. Okay, so in theory, let's take a look at our log. If I push the button now, it should send a message to our WebStream node. Before I do that, I'm getting back to my console here. And I want to take a look at the log of the WebStream node. So let me click the button here. Okay, so here is the log from the board, which says, okay, I'm sending a post request to this endpoint. This is the local IP of my desktop computer where the WebStream node is running. to this specific endpoint. As you can see, the endpoint has the name of the project I want to send the message to. And the body of the message is containing a payload object with the account I want to send rewards to. As you see, it's my Metamask account here. And then header object that includes whatever the WebStream protocol expects to. So the event type, the publisher ID, the time, and the token. So that's what the board has sent to WebStream. WebStream has responded with successful and just some log data here. It's basically logging which applet ID has been called because of this message, and there are no errors. So let's get to the WebStream log here. Now that's where JQ is helpful. So I'm closing the log and logging again and adding, piping this into JQ to see a better output. So let's take a look here. So WebStream is saying that he received a message whose event code was click. And this click event matched one event strategy. And this event strategy that belonged to the click to earn project. So here is where WebStream is building like the message or the event for the handler, because before calling it, and then it says, okay, I'm calling the handler start, because that's what's written inside the event strategy. So from now on, we see the log of the start function that we created in Golang. So if you remember, we logged this message so that the WebStream logic has been called with this event ID, right? We logged this one inside our click-to-earn.go just to make sure the event has been called. So the handler has been called. So our function logic keeps going on. So it's logging the account that has been found inside the message. Right? So it's first extracting the payload from the event, from the WebStream event, and then from the payload, it's logging the account. Then it's reading the number of clicks from the database. It's increasing by 1, so it's 0, it becomes 1. It's logging the number of clicks, it's 1. And then eventually it's finished, because with 1 click we don't do anything. Right? So if we keep, I will make this a bit smaller here to enable you, to allow you to see better the number of clicks here. It's right at the top here in the log. So if I keep pushing, so one more time, so it's 2 clicks, 3 clicks, 4 clicks. Now if I click once more, we do 5 clicks. So we expect that our logic will detect that we have clicked 5 times, and so it will send a transaction to the blockchain, to the token contract, calling the mint function and passing this account as the recipient, the account that's mentioned inside the message, and it will mint 1 token to that account. And because the account is the same that I used in Metamask, we should be able to see the balance there. So I click once more. So as you can see, number of clicks is now 5. So our function says, okay, I'm minting 1 click token to this destination address. That's the one we put inside the firmware. Sending the blockchain transaction. And it's also providing the blockchain hash for this transaction for you to check if anything was failed or reverted or anything. Transaction was sent successfully, and that's the event management is completed. So if I go to my Metamask wallet, right here, I should see I have 1 click token. So as you can see, I've been sent 1 click token. So I've been assigned one click token inside the click token smart contract. So I can keep going here and click more and earn more. So, right, click 6. There is a delay of a few seconds inside the firmware. 7. So I'm stop sending messages with the board. I'm just showing you how you can send messages without the board. So if you click on the project here, you can use the send event button. This is for testing your logic. So you select the project you want to send a message to. You select the publisher you want to use to authorize your message. And then you can edit your payload here. So it's already creating the message for you. The event type has to be click. Otherwise, our event strategy will not trigger. The publisher ID is automatically filled. Publishing time is filled. So you will only have to set the payload. I will copy it from. It's just a simple JSON object with an account field and the recipient account where we want to send the tokens to. There should be no example field and no. Okay. So this is how the payload looks like. It's a string, and the string is a JSON object that contains only the account field and the rewording, the address that we want to reword. So if I send again, now the number of clicks is 8. You see? So if making this a bit smaller again. So number of clicks is 8. So I keep sending. It's 9. So now it's 10, and it's sending a blockchain transaction again. So now I should have 2 clicks tokens at some point here. Okay. So we now have 2 click tokens. And so on and so forth. The more you click, the more you earn. Of course, you're not earning anything because we just deployed this contract, and this token has no value because there is no token economy bound to this token. So depending on what our application is and what is the utility that we give to this token, then people could be more or less incentivized to click or to do whatever data collection our board is built for. Okay, I think I've completed the workshop. I see one question in the chat from Adam. Anybody, if you want to open your microphone and ask questions, feel free to do so. So Ade is asking, what's the recommended Arduino specifications again? So if you use the ESP32, the firmware included in the repository will work out of the box, exactly the way I did it during the workshop. The only maybe slight difference, if you have a slightly different board, could be the button logic. In my case, the is pressed function is true when the button pin returns 0, because it uses an inverted logic. So you can invert this here. In your case, if it doesn't work, it could be that it keeps sending messages because it's always low in your case. In my case, it's always high. So you can have a different logic for your button. In this case, you just invert it here, or you invert the logic of the button in the setup. Yeah, in the setup here, you can say that the button is, instead of pull up, you can choose any different logic for your button. But the ESP32 node MCU is the one that I've used. In general, any Arduino that is based on this popular SAMD21 chip, like the Arduino Nano 33 IoT, the Arduino Nano BLE, and I think also some maker boards should also work. You only have to set up the specific pin for your board that where you are actually wiring the button that you are pushing. Yeah, that's it. Again, if you want to replicate this workshop, you can do so by going to the developer portal, to the IoTeX developer portal, developers.iotex.io. It's the main get started guide for Machine-Fi, this one. And if you have troubles or you need support or you need help, you can just go to the Discord server, iotex.io/dev Discord, or you find it also here in the community links in the developer portal, Discord. And inside the Discord server, we have a nice developers lounge where you can just join and ask questions, ask for help. If you want to customize the project and build something different, you will find a community there that will help you. Yeah, our Twitter is IoTeX_dev. That's our Twitter account. So it's normal if you could not follow along, but I definitely encourage you to register to the developer portal, fetch the test tokens like I did during the workshop, and start experimenting with this same workshop on the homepage, and then reach out to us in the community.
Thank you very much. As we close, we have one comment on the chat, which is thank you for this intuitive presentation. Looking forward for more like. So I believe that's quite encouraging. And yes, I think I'd like to wish everyone a lovely weekend. Simone, I believe we'll be able to finalize on a proper recording so that you can also be able to share with the community and for guys to be able to work with. And also for the engineering society, because it cuts across multiple universities across Africa. So they're also interested to see the recording and see what they can be able to build. Because I believe the last 2 weeks we've been just going through a couple of universities and checking some of the projects which they've worked on. And actually 80% of them are hardware-based. A few are actually software-based. So that's also something you can be able to explore on also.
Okay, thank you, Simon, and well done. Very innovative technology and everything. So I'm just curious if there's a research going on for more use cases for this project, and for some people that might be interested in like really going deep into this your innovation. If you have a research, would I say, faculty for it, where you are working on how to like commercialize this innovation.
Yeah. So in terms of use cases, this is a whole new market. So there are so many use cases. Once you can really like inject proofs of real world events into smart contracts, you are actually connecting the decentralized finance with the real world finance economy, right? And so you can start really applying this Web3 technology to the real world economy, which is much bigger than the current economy that is run by the Web3 ecosystems. So there are many use cases. So for the use cases, I would invite you maybe to check out the latest video. Here we go. So this one is a recent, couple days ago video where there was also co-founders of IoTeX at the end. But if you pay attention to Larry's presentation, he's going through what you can actually build with Machine-Fi and what are the possible use cases, starting from the simplest architecture to the more complex ones. And this gives you a good idea of what to expect from this Machine-Fi technology. Of course, WebStream is enabling this. Is like the tool that makes it easier to connect data from machines to blockchain applications, but it's much more complex than what you have seen in this workshop. This is only to get the tools working, but there are many details to take care of when connecting real-world data to blockchain applications, and mainly they are how to register identities of devices to make sure that people are not using other devices that are impersonating the real devices, or simulators that are impersonating your device and sending fake data that could just destroy your token economy, right? This is the most important part, how to trust the data that you are receiving. Then WebStream is also in a very early release. This is an alpha release. Actually, we call it a developer seed release. Additional components that we will add to the next releases toward 2023 and 2024. So allowing for more storage options and for more device identities management, again based on blockchain, not on a simple publisher account like you have seen in this workshop, as well as how to face privacy concerns, right? There are all these things that have to be implemented. And currently what you can do, you can learn, starting getting familiar with this concept, starting running some basic projects and experimenting. And then slowly, when WebStream will become more and more a full feature, you will be able to implement more complex aspects of a machine-fi application.
I wanted to ask regarding the compatibility of utilizing WebStream in hybrid smart contracts alongside Chainlink.
You mean a smart contract that uses both Chainlink and WebStream?
Yes.
Yeah, so these are just two different services. Also, WebStream is very different from Chainlink. Chainlink is one specific oracle that provides some specific data. The most used one is for price asset data. But IoTeX, the IoTeX WebStream is not a specific network, it's a framework. So in this workshop, we have shown how to just provide a proof of click to a smart contract. But it could be anything. You can use WebStream to build your network that feeds data to smart contracts. And this data can be basically just proofs based on IoT data that has been collected from smart devices and stored inside the WebStream storage layer. And then on top of all this data, your WebStream logic can perform, any IoT logic can compute any proof, and then the proof is what is sent to a smart contract. And it could be a proof of anything. So could be a proof of you walking 10 miles every day, or could be a proof that you contributed a certain amount of data to a data pool. So it can be just anything. It's a framework. It depends on what you build. So on the other side, if you're creating a smart contract, you can have a smart contract that uses Chainlink to implement some DeFi application. And then your DeFi application can also use an existing WebStream network, right? Either you created it or somebody else created it to fetch some proofs of something from the real world to be used together with the rest of your DeFi logic. So for example, I just sharing a very simple example. Let's say it's a GPS related type of WebStream network that anybody can use. And for example, you could use it to fetch GPS location data of your users. And for example, in your DeFi contract that's using also Chainlink, you could need the proof of location of these users. This data is going to be stored inside the WebStream network. And this WebStream network becomes an oracle for your smart contract. So your smart contract can fetch data from Chainlink, can fetch data from any other oracle, can fetch data from this WebStream oracle to query if a specific blockchain address is located in a specific region of the world. And this oracle will reply you with a trusted proof that if that blockchain account is being used in a specific location of the world or not. And then you can use this information, for example, if it's an NFT game, you could take trusted location from this WebStream network to mint some NFT tokens, I don't know, based on the logic of your Pokemon-like type of smart contract. So yeah, definitely you can fetch WebStream data, but the difference is that it's not that you fetch data from WebStream, right? There must be a WebStream network deployed that provides data to your smart contract. And then you can use your smart contract to fetch data from this WebStream Oracle or from Chainlink and from any other Oracle that you trust. I hope I answered the question.
Yes, you did. Thank you.
Sure.
It seems there are no other questions. Thank you so much, Simon. Thank you everyone for joining the workshop at a slightly short notice. And I wish everyone a lovely day. Thank you.